Good evening, Lakshana and Ariston.
Good evening, ma'am.
Good evening, ma'am.
Good evening. Good evening. Yeah. So don't take out your notebooks. Don't write anything today. Just listen to what I'm explaining, and you can complete the notes by the next class. All right?
Yes,
All-
ma'am.
Yeah. So just help me to figure out where I stopped in the last class. This is exercise 11.3. I'll just take you through the questions. Just let me know if we finished. I think this one we finished. Suitcase sum we finished. This also we finished. Yeah, this we finished. Yeah, we did this. Yeah, I think we need to continue from here.
Yes, ma'am.
Okay, right. Okay, so as I told you, this is NCRT exercise 11.3, question number 8. The lateral surface area of a hollow cylinder is 4,224 centimeters square. The lateral surface area meaning the curved surface area. So the formula to find the CSA of a cylinder is, what's the formula to find the CSA of a cylinder? Okay, no answer. So 2 pi, yeah,
Ma'am, 2 pi RH.
yeah, 2 pi RH. So the value of 2 pi RH is given to us. 2 pi RH is equal to 4,224. This is given to us. It's cut along its height. It's cut along its height. That is, the cylinder is cut along its height and formed a rectangular sheet of width 33 centimeters. Find the perimeter of the rectangular sheet. All right. So the cylinder is cut along its height. So when you cut open the cylinder and when you spread it open, it's a rectangle. A hollow cylinder. So I showed you the other day when you make a cylinder using a paper. Yeah, see here I have a rectangular piece of paper. So a rectangular piece of paper. So when you roll it, when you bring the opposite edges together, you can form a cylinder. When you bring the opposite edges together, you can form a cylinder. When you have a rectangular piece of paper, you bring the opposite edges together, it forms a cylinder. Now, when you cut open the cylinder, along its height and you spread the cylinder open, now you've cut it, right? So you spread it open, it's a rectangular sheet. It's a rectangular sheet. Using a rectangular sheet, you can bring the opposite edges together and form a hollow cylinder. When you cut open the hollow cylinder, in this case along the height, when you cut open the cylinder along the height, and the cylinder opens up now. So now it's a rectangular sheet. All right. So it's cut along its height and formed a rectangular sheet of width 33 centimeters. Find the perimeter of the rectangular sheet. So see here. So the lateral surface area is given to be this one. This will be the area of the rectangular sheet also. Whatever is the curved surface area of the cylinder will be the area of the rectangular sheet also. So the area of the rectangular sheet is equal to the lateral surface area of the cylinder, 4224. So area of a rectangle is L into B. So L into B is equal to 4224. The width of the rectangle is given to us. So L into 33. This is L, children, not 1, L. L into 33 is equal to 4224. So L is equal to 4224 divided by 33. So the length of the rectangle formed is 128 centimeters. The length of the rectangle formed is 128 centimeters. The question is to find the perimeter of the rectangular sheet. So we know the formula to find the perimeter of a rectangle, 2 into L plus B. So 2 into L, this is length, plus breadth. So when you work that, you get 322 centimeters. So in this question, a hollow cylinder is cut along its height and spread open. So what you see is a rectangular sheet. The width of the rectangular sheet is given to you, 33 centimeters. So using this, you have to find the length of the rectangular sheet. Whatever is the curved surface area of the hollow cylinder, whatever is the CSA of the hollow cylinder, will be the area of the paper. So area we know is L into B. Area of a rectangle is L into B. Substitute for B, 33. So you can work and find the value of L. Now you know the length of the rectangle and the breadth of the rectangle. So find the perimeter of the rectangular sheet using the formula 2 into L plus B. So that's about question number 8. So here a road roller takes 750 complete revolutions to move once over to level a road. Find the area of the road if the diameter of a road roller is 84 centimeters and length is 1 meter. So see here, this is the length. This is the length of the road roller. This one is the length. This one is the length. The radius is here. The diameter is this one. This is the diameter. This is the diameter. So diameter and the height. The height is this one. This is the height. This is the height of the road roller. Not this one. Not this one. This is the diameter. This one is the diameter of the road roller. This one is the height of the road roller. This one. All right. So it's given that the road roller takes 750 complete revolutions to move once over to level a road. So imagine this is the road. This is the road. This is the road. The road roller has to roll over this 750. Has to roll 750. Okay. Has to make 750 complete revolutions to level the road. So the area of the road will be the area covered by the roller in 750 revolutions. So what is the area covered in one revolution? The area covered in one revolution will be the curved surface area of the cylinder. Because when the cylinder rolls over the ground or goes over the road, it is the curved surface area of the cylinder that comes in contact with the road. The total surface area of the cylinder does not come in contact with the road. What rolls over the road? What part of the cylinder comes in contact with the road? Only the CSA. Only the CSA. See here? Cylinder. The circular portion, these two circular portions, see this one. These circular portion, this one and the other side, which we can't see in this figure. So this one and the other side, these portions do not come in contact with the road. It's only the CSA that rolls over the ground or the road. So the area covered by the cylinder or the area covered by the road roller in going one complete revolution is equal to the CSA of the road roller. The curved surface area of the road roller, that is area. When you find CSA of the road roller, that's area. That is the area covered by the road roller in going one complete revolution. So one revolution, area covered is the CSA. Sorry. Yeah. So the area covered in one revolution. Area covered in one revolution is equal to 2 pi RH, because that is the formula to find the CSA of a cylinder. So this is the area covered in one revolution. So the area covered in 750 revolutions will be 750 into 2 pi RH. 750 into 2 pi RH. And that will be equal to the area of the road. So what we understand is area covered in one revolution is equal to the CSA of the cylinder. Area covered in one revolution is equal to the CSA of the cylinder because it is only the CSA that comes in contact with the road. And when we say area covered in one revolution, it is the area of the road covered in one revolution. When we say area covered, what area covered? The area of the road or the area of the ground covered in one revolution. That's what is meant by this. The area of the road or the area of the ground covered in one revolution is equal to the CSA of the cylinder. So that is 2 pi RH. So 2 pi RH is the area covered in, is the area of the road covered in one revolution. So into 750 will give you the area of the road. So the diameter is given 84 centimeters. Radius is equal to 84 by 2, 42 centimeters. And the height of the road roll is 1 meter, so 100 centimeters. See this. Diameter, radius, height is 1 meter, which is 100 centimeters. Number of revolutions, 750. The area of the road is equal to the CSA of the roller, curved surface area of the roller, into number of revolutions. 2 pi RH into 750. 2 into 22 by 7 into 42 into 100. You must have both radius and height in the same unit. You cannot substitute radius in centimeter and height in meters. Both must be in centimeters or both must be in meters. Same unit, basically. So 2 pi RH into 750. So this is the value. So many centimeters square. To convert centimeter to meter, we need to divide by 100. To convert centimeter square to meter square, do that 2 times. So see here, divide by 100, but another 100 because we'll have to convert centimeter square to meter square. So that gives us 1980. 1980 meter square is the area of the road. Yeah, that's about this one. I think this we finished the other day. 10 I finished. Yeah. These were the 2 questions I said we'll do it in the next class. Right, so this finishes 11.3. And children, the images I've already shared with you, right? The images of exercises 11.3 and 11.4 have already been shared with you, right?
Yes, ma'am.
Yeah. So that's why I didn't ask you to take a screenshot now. You already have the answers. All right. I think I had asked you to complete the notes also, if I'm not wrong. Correct?
Yeah, ma'am.
Yeah, right. Okay, fine. Correct. I'll let you know. So this is in NCERT, this is the last exercise, 11.4. So here, find the height of a cuboid. Height of a cuboid whose volume is given and base area is given. So cuboid, we know the formula to find the volume of a cuboid. Volume of cuboid is equal to L into B into H. This is the formula to find the volume of a cuboid, L into B into H, where L into B is the base area. L into B is the base area, area of the base. What is the base of a cuboid? It's a rectangle. The base of a cuboid is a rectangle and area of a rectangle is L into B. So that's what is given. Base area is given. So L into B is given 25. Into H is not known, is equal to the volume 275. 275. So H will be equal to 275 divided by 25, which is 11. You do it again. You can do it like this. Volume is given to be 275. Volume means L into B into H is equal to 275. Base area is L into B, that is 25. So 25 into H is equal to 275. So H is equal to 275 divided by 25. H is equal to 11. So we start like this. Volume is given. Volume means L into B into H, 275. L into B, base area is 25. So L into B is 25. Into H is equal to 275. So work this and find the value of H. And that's the height of the cuboid. Okay. A go down is in the form of a cuboid of measure 60 meters by 40 meters by 30 meters. So these are the dimensions of the go down. The go down is 60 meters long, 40 meters wide, and 30 meters high. So we can find the volume of the go down. L into B into H will give us the volume of the go down. The question is, how many cuboidal boxes can be stored in it if the volume of one box is 0.8 meter cubed? So it's like this. Supposing you have a container, and the volume of the container is say 50 centimeter cubed. Okay. Yeah. So you have a container. The volume of the container is 50 centimeter cube. Now say you want to store ice cubes in this container. All right, you're going to put it inside the freezer. If you leave it outside, it's going to melt. So you have some ice cubes, and the volume of each ice cube is say 2 centimeter cubed. The volume of each ice cube is 2 centimeter cubed. The volume of the container is 50 centimeter cubed. The volume of each ice cube is 2 centimeter cubed. Then how many ice cubes can be placed in this container? I'm asking you a question. How many ice cubes can be placed in this container? No? Okay. Now I need to ask if I'm audible or am I talking to myself? Am I audible to all of you? Lakshana, Ariston, and Harsha?
Yes, ma'am.
Okay, fine. Thank you. So if the volume of the container is 50 centimeter cubed and the volume of each ice cube is 2 centimeter cube, then we can store 50 by 2, 25 ice cubes in this. We can store 25 ice cubes in this. The volume of the container, the vessel is 50 centimeter cubed. The volume of each unit you're going to store in this container is 2 centimeter cubed. Whatever you store, need not be ice cube. You're storing something, and the volume of each unit you're storing is 2 centimeter cubed. Maybe a sweet. So you have, you have so many sweets, and each sweet has a volume of 2 centimeter cubed. So how many such sweets can be placed in this container? 50 by 2, 25. So I've told you, I've mentioned this once earlier, that volume by volume will give us a number, and area by area also will give us a number. When you divide area by area, it will give you a number. Volume by volume also will give you a number. I'll give you an example for that. Now, supposing you have the floor area say of a bathroom, you have the floor area of a bathroom. The floor area is say 200 centimeter square. The floor area, let me take meter square. Okay, the floor area of a bathroom is 200 meters square. and say the area of each tile, area of one tile. Area of one tile is 5 meters square. All right. The floor area of a bathroom is 200 meters square. So you're going to lay tiles in the bathroom. The floor of the bathroom is going to be tiled. The area of each tile is 5 meters square. Then the number of tiles we need to buy will be equal to 200 by 5, which is 40. Number of tiles needed. Number of tiles needed is equal to 200 by 5, 40. The floor area of the bathroom is, see, in the bathroom, even the walls are tiled. We are not talking about the walls. We are talking only about the floor being tiled. The walls are also tiled, but we are not talking about that. Our situation is only about the floor area and tiling up the floor area. So floor area is 200 meters square. And the area of each tile you're going to lay on the floor is 5 meters square. Then the number of tiles needed will be the floor area 200 divided by the area of one tile, which is 40. So area by area, floor area by area of one tile. The bigger area in the numerator, the smaller area in the denominator. The bathroom area, the floor area is the greater one, divided by the area of one tile, which is smaller than the area of the bathroom. So the bigger area in the numerator, the smaller area in the denominator. So area by area here will help us to find the number of tiles. Volume by volume. In this case, volume by volume will help us to find the number of cuboidal boxes that can be stored. Volume by volume, volume of the go down divided by the volume of each cuboidal box will help us find the number of boxes that can be stored in the go down. So number of boxes is equal to volume of the go down by volume of one box. Volume of the go down by volume of one box. Volume of the go down is L into B into H. Cuboid, no? So length, breadth, height. 60 into 40 into 30. Divided by the volume of one box. Volume is given straight away. You don't have to find. It's given. The volume is only 0.8 meter cubed. That's the volume straight away. So divided by 0.8. Now, why have we multiplied and divided by 10? Because we want to shift the decimal point for that reason. See, if you think, no, I know how to cancel like this, you can cancel. If you want to shift the decimal point, then you should do this. Otherwise, you don't have to do this. If you think you can cancel straight away, 8 ones are 8. 850 times is 40. I'm sorry, 0.8. Ones are 0.850s are. Fine, you can do that. If you want to simplify straight away, you can do that, children. If you want to shift the decimal point, so you multiply the denominator by 10. So you have to multiply the numerator also by 10. So now 0.8 into 10 becomes 8. And in the numerator, 60 into 40 into 30 into 10. Now simplify 8 ones are 8 fives are, and the product is 90,000. So the number of boxes that can be stored in the go down is equal to 90,000. The unit in the numerator and the denominator is the same. Numerator meter cube, denominator also meter cube. Yeah, any clarifications? Please tell me, any clarifications? Any questions?
No, ma'am.
Okay. Ariston, Harsha?
Yes, ma'am.
Any clarifications?
No, ma'am.
No, ma'am.
Okay. Yeah. A rectangular paper of width 14 centimeters is rolled along its width. So see here, a rectangular paper, you can see the picture here, of width 14 centimeters is rolled along its width, and a cylinder of radius 20 centimeters is formed. Find the volume of the cylinder. So to find the volume of the cylinder, the formula is pi r square h. The radius of the cylinder, 20. Height of the cylinder, 14. So you have the values straight away. So just use the values and find the volume. Using this paper, a cylinder is formed. Using this paper, a cylinder is formed. The height of the cylinder is 14 centimeters. And the radius of the cylinder formed is 20 centimeters. It's given to us. We don't have to find anything. With this information, find the volume of the cylinder. So volume formula, pi r square h. R is 20. H is 14. So pi 22 by 7. R square 20 into 20 into H 14. So work this and find the volume. So this is simple. So here, a rectangular piece of paper, 11 centimeters by 4 centimeters, is folded without overlapping to make a cylinder of height 4 centimeters. Find the volume of the cylinder. So the difference between the earlier question and this question is that in the earlier question, we didn't have to find anything. The radius and the height of the cylinder formed was given to us. So we just had to use the formula, fix the values in the formula and calculate. But here we only know the height of the cylinder. Here we only know the height of the cylinder. We have to find the volume. We don't know the radius. The radius is not given. So we have to find the radius. Now, this length of 11 centimeters, this length of 11 centimeters has now become a circle, in the cylinder. This line segment, 11 centimeters, is now in the form of this circle in the cylinder. This 11 centimeters is maybe here. I can say this 11 centimeters is here in the bottom circle, and this 11 centimeters is here in the top circle, And this one becomes the height of the cylinder, 4 centimeters. Since the cylinder is formed using this paper, and this paper or the ends of the paper just meet, they don't overlap. Okay, they just meet to form a cylinder. So this length, 11 centimeters, and this length, 11 centimeters, are now circles in the cylinder. That 11 centimeter is a circle here in the cylinder. And the 11 centimeters here is also a circle below in the cylinder. So that means 11 centimeters now is equal to the circumference of the circle, not area, because this length is now here. And what is this for a circle? Circumference, 2 pi r. So 2 pi r is equal to 11. We need to use this equation. 2 pi r is equal to 11. And on working this, you can find the value of r. So very simple. This is 11 centimeters. Where is this one? This line segment is now this circle in the cylinder. So the length of the circle is 11 centimeters. And what's the formula to find the length of the circle or the circumference of the circle? 2 pi r is the formula. So the answer, the value of 2 pi r is 11. The value of 2 pi r is 11, which means 2 into 22 by 7 into r is equal to 11. So r is equal to 11 into 7 by 22 into 1 by 2. R is equal to 11 into 22 by 7 becomes 7 by 22 and 2 by 1 becomes 1 by 2 on the other side. So 11 ones are, 11 twos are. So R is equal to 7 by 4. R is equal to 7 by 4. So like this, we have to find the radius here. In the previous question, radius and height both were given to us. So we found the volume of the cylinder using the formula pi r square h. Here we have to find the volume, same question, but the radius is not given. We have to find the radius and then find the volume. So what I've written here is the circumference of the circle is equal to the length of the rectangle. You can see here. Length of the rectangle, let me read from the beginning. Rectangular paper. For the rectangular paper, length is 11 centimeters. Breadth is 4 centimeters. Now cylinder, breadth of the paper becomes the height of the cylinder. Yeah, this breadth of the cylinder becomes the breadth of the rectangle becomes the height of the cylinder. Correct. The breadth here, the breadth of the rectangle becomes the height of the cylinder. Correct. Breadth of the paper becomes height of the cylinder. So height of the cylinder is 4 centimeters. Radius we don't know. We don't know the radius of the cylinder. So length of the rectangular paper, this is the length of the rectangular paper, becomes the circular base of the cylinder. Circular base and the circular top also. Becomes a circular base of this one becomes this circular base, and this one becomes this circular base, the circular top. So that means circumference is equal to the length of the rectangle. 2 pi r is equal to L. 2 pi r is equal to 11. So 2 into 22 by 7 into r is equal to 11. So as I told you, work and find the value of r, 7 by 4. Now find the volume using the formula pi r square h. Pi r square 7 by 4 into 7 by 4 into h 4. So that gives you 38.5 centimeters cube. Volume, no? So centimeter cube. Yeah, children. You don't have to write all this theory. This just to understand. You can directly write this. You can just write height of the cylinder. See, for the cylinder, it's enough if you write this also. For the cylinder, h is equal to 4, and then you can write 2 pi r is equal to L. 2 pi r. This is 2 pi r. Is equal to the length of the rectangle. You don't have to mention all this. I've just given the description, that's all. You can just write this directly. H is equal to 4 and then 2 pi r is equal to L. You need not write all this. Okay. So given a cylindrical tank, in which situation will you find surface area? And in which situation volume? When will you find the surface area? When will you calculate the volume? Okay, they've given you the situations. The first situation, if you have to find how much it can hold, will you find volume or area? The question is for you, children.
Volume.
Volume, correct. So if you have to pour something into the container, then it is volume. So to find out how much it can hold is volume. Next, number of cement bags required to plaster it. What will you find? Where will you plaster? Where will you plaster? Now a building, no? Where is the building plastered? Plaster is splashing that, that mixture of cement and whatever stuff, they splash it on the wall and they smoothen it, right? That is plastering. Where is it done? Plastering.
Ma'am, on the surface area.
Surface area on the wall. Wall meaning surface area. The wall is plastered. It may be the inside of the wall or the outside of the wall. But plaster is not poured inside the room. That mixture, that plaster is not poured inside the room. It's splashed on the walls, the ceiling, the wall. So it has got to do something with the area. So the number of cement bags required to plaster it. So for plastering, you'll find the area. Then to find the number of smaller tanks that can be filled with water from it.
Volume.
Volume. So to find the number of smaller tanks that can be filled with water from it. So you have to find the volume here because again, it's about the capacity. Filled with water. You're doing something inside. Next one. Oh yeah, you can see the answer here. So to find how much it can hold, its volume, number of cement bags required to plaster it. So since the plastering activity is on the walls and the ceiling, it is surface area. Next one, to find the number of smaller tanks that can be filled with water from it. So water filling is all about volume. So here I don't have to read this big question for you, but you can see it in the diagram here. Cylinder A and cylinder B. So what is the radius? Ariston, what is the radius of the first cylinder? Ariston. Harsha, what is the radius of the first cylinder? Okay, Lakshana.
Ma'am,
Ma'am,
7
it's three-
is 3.5.
Correct. The radius of the first cylinder is 7/2 or 3.5. What's the radius of the second cylinder?
Ma'am, 7.
7. Height of the first cylinder?
14.
14. And the height of the second cylinder?
7.
7. So radius is what we'll have to be careful. 7 is the diameter. For the first cylinder, 7 is the diameter. So radius is 7/2. Second cylinder, diameter is 14. So radius is 14/2, 7. So you need to check, whether the cylinder with a great, okay, the question is without doing any calculations, can you suggest whose volume is greater? Verify it by finding the volume of both the cylinders. Check whether the cylinder with a greater volume also has greater surface area. Okay, so first you'll have to guess. First you'll have to make a guess as to which cylinder will have greater volume. Okay, then you should also work and find out the volume of the two cylinders, the actual volume of the two cylinders. The first thing is you will have to take a guess which cylinder will have more volume. Okay, next you'll have to actually calculate the volume of the two cylinders. Using the radius and height, you'll have to actually calculate the volume using the formula. And then you'll have to check if the cylinder with the greater volume also has greater surface area, which means you'll have to find the volume of both the cylinders and the surface area of both the cylinders and compare. So I've called the radius and height of the first cylinder as R1 and H1. The radius and the height of the second cylinder as R2 and H2. Radius and height of the first cylinder, cylinder A, as R1, H1. Radius and height of the cylinder B, R2, H2. So write the values of the radius and height of the two cylinders and find their volumes and surface areas. Yeah. So if nothing is mentioned, children, it's just given which one has a greater surface area. There is no mention of curved surface area or total surface area. If nothing is mentioned, you have to find the TSA. If nothing is mentioned, you have to find the TSA, total surface area. So you can see here, volume of cylinder A, pi R1 square H1 cubic units. Substitute the values and calculate the volume. Cylinder B, pi R2 square H2, because pi R square H is the formula. R1 H1. Again, for the second one, pi R square H is the formula. R2 H2. Write the formula pi R square H. Then R1 H1, just put R1 H1. Then for the next one also, volume is pi R square H. But write it as R2 and H2. So like this, you can find the volume of the two cylinders. And you can see that the volume of the second cylinder is more than the volume of the first cylinder. Similarly, surface area, since nothing is mentioned, you'll have to find the TSA. 2 pi RH, sorry, 2 pi R into R plus H, 2 pi R into R plus H, put R1 and H1. Similarly, for the next one, 2 pi R into R plus H, R2 and H2. So substitute the values and calculate. So you can see that in this case, the surface area of B is greater than the surface area of A. This need not always be true. When the volumes are compared like this, the areas can be compared in the reverse order also. Like maybe the surface area of A is greater than the surface area of B. You can't say. In this case, both the volume and the surface area of the second cylinder, that is cylinder B, is greater than the volume and the surface area of cylinder A in this case. So this is a pretty straightforward question to find volume and surface area and compare. So we are given the volume of a cuboid. Volume of cuboid is given to us 900 centimeter cube. Volume is nothing. Volume of a cuboid is given by L into B into H is equal to 900. But the base area, that is L into B, base area L into B is 180 into H is equal to 900. So H is equal to 900 divided by 180. H is equal to 5 centimeters. So the height of the cuboid is 5 centimeters. Next one. A cuboid is of dimensions 60 centimeters by 54 centimeters by 30 centimeters. How many small cubes with side 6 centimeters can be placed in the given cuboid? So whenever we have to find a number, it is always volume by volume or area by area. So how many small cubes? You'll have to find the number of small cubes. Number of small cubes. So number of small cubes that can be placed is equal to volume of the big thing. So volume of cuboid divided by volume of each cube, each small cube. Each small cube. See, there's a cuboid of dimension 60, 54, 30. The question is how many small cubes of side 6 centimeters can be placed in the given cuboid. So the number of small cubes will be equal to the volume of the bigger one. So volume of the container, the cuboid, divided by the volume of each small cube. So cuboid, the formula is L into B into H. So 60 into 54 into volume, L into B into H. And volume of a cube is A cubed, 6 into 6 into 6. Both are in centimeter. See here also the dimensions of the cuboid in centimeter, and the edge of the cube is also in centimeter. So we don't have to convert anything. Now simplify this. 6 ones are 6 tens are 6 ones are 6 nines are 54. 6 ones are 6 fives are. So 45 into 10, 450 cubes can be placed. 450 cubes can be placed. Number of small cubes is equal. The number of small cubes that can be placed in the cuboid is equal to volume of the cuboid. The bigger thing, the volume of the vessel, the volume of the cuboid divided by volume of each small cube. What you should not do is you should not find separately like this. You must not find volume of cuboid is equal to 60 into 54 into 30. You should not do this multiplication. You should not do this multiplication. See, like when you multiply 60 into 54 into 30. So you get 97200. So you're spending time multiplying centimeter cubed. Then you will find volume of each cube, each small cube. Volume of each small cube is equal to 6 cube. That is 216 centimeter cube. Now number of cubes. Number of cubes will be equal to 97200 divided by 216. Now again you'll have to divide. So you're going to take so much time. But this is time consuming. See, here you had to find the product. Here also, if you didn't know 6 cubed, you'll have to work that. And then when you find the number of cubes, that is this one divided by this one, again, this calculation will take a little time. So whenever we have to find the number, don't find volume of the cuboid and volume of each small cube separately. Don't do that. Directly find using the formula number of cubes is equal to volume of the cuboid by volume of each small cube. Do the division straight away like this. Don't find separately is what I'm trying to say. Don't find the volume of the cuboid, volume of each small cube, because you will be taking time in calculation. You should find the number of cubes straight away. Straight away like this. So volume of the cuboid, formula is L into B into H. And 1 cube is A cubed. So substitute like this and then cancelling. I've always, told you I cannot do that here. So 6 ones are 6 tens are like this. So 6 ones are 6 nines are 54. 6 ones are 6 fives are. So 450 cubes. So here the volume of the cylinder is given. Volume of cylinder is equal to 1.54 meter cubed. But you can see that the diameter of the base is given in centimeter. The diameter of the base is given in centimeter. So how do we convert, children? How do you convert meter cube to centimeter cubed? Yeah, how do we convert meter cube to centimeter cube?
Ma'am, multiplying by 10,000.
No. How do you convert meter to centimeter? Yeah, meter to centimeter.
Ma'am, multiply by 100.
Okay, so meter square to centimeter square. Yeah, to convert meter square to centimeter square.
Should we multiply it by 100 for meter square also and centimeter square?
Ma'am, multiplying by 10,000.
Okay, so 1 minute. See, let me tell you. Supposing we have to convert 2 meter cube. 2 meter. 2 meter, 2 centimeter. So 2 into 100 centimeters. 2 meter square to centimeter square. You should do the same thing 2 times into 100 into 100. 2 meter cubed to centimeter cubed. You need to do the same thing 3 times into 100 into 100 into 100. When to convert meter to centimeter, you need to multiply by 100. Meter square to centimeter square, do that same thing 2 times. Meter cube to centimeter cubed, do this one 3 times. Now, supposing you have say like 600 centimeters. To convert 600 centimeters to meters, you need to divide by 100. 600 centimeters to meters, you need to divide by 100. So 600 by 100, that is 6 meters. To convert 600 centimeters square to meter square, centimeter to meter, divide by 100. Centimeter square, you want to convert that to meter square. So you should divide by 100 2 times. So to convert 600 centimeter cubed to meter cube, you need to do the same thing 3 times. Centimeter to meter, you need to divide by 100. To convert centimeter square to meter square, do that same thing 2 times. So divide by 100. No, divide by 100 2 times. 100, 100. Centimeter cube to meter cube. To convert centimeter to meter, you divide by 100. So centimeter cube to meter cube, do that same thing 3 times. So the answer here will be 2 zeros and 2 zeros gets cancelled. 6 by 100 is 0.06 meters. 0.06 meters. And here the answer will be 2 zeros and 2 zeros gets cancelled. So we have 6 by 1212 meter cubed, which will be 0.123 and 6 meter cubed. Shift the decimal point. Because it is 6 by 10,000. So the decimal point is here. You need to move that by 4 places. 1, 2, 3, and 4. It comes here. So the remaining places are zeros. 0. And before the decimal point, you can always write a 0. So 0.0006 meter cubed. Now tell me, Lakshana. How do you convert meter cube to centimeter cube?
Ma'am, multiply by 100 3 times.
3 times. 100 3 times. So it is 1 followed by 6 zeros. So meter to centimeter. To convert meter to centimeter, we need to multiply by 100. Meter cube to centimeter cube. Do that 3 times. Whatever you do it 3 times. So into 100, into 100, into 100. So then it's converted to centimeter cube. So this is 154.1212 centimeter cubed. So this is the volume. This is the volume. So volume formula for a cylinder is pi r square h is equal to 154.1212. So 22 by 7 into r square. Diameter is 140. So r will be 140 by 270. 140 by 270. So 70 into 70 into h is equal to 154.1212. So we'll have to solve this and find the value of h. So you can see there is one equation and only one unknown h. So you can solve this and find the value of h. See the answer here. Children, just give me 5 minutes. Go through all the working. I'll come back and ask you questions. So what you see here are not three different methods or something. We have to find the height of the cylinder. And for that, volume is given, volume of the cylinder is given. So pi r square h is equal to, whatever value is given. We substitute the values and we find the value of h. That is what is everywhere. In the three different methods, we just see how you can convert centimeter to meter or meter to centimeter, and do it. So in the first method, what I've done is I've converted the radius of 70 centimeters to meters. Because you see that the volume is given in meter cubed. The volume is given in meter cubed, but the diameter of the base is in centimeter. So you need to have uniformity with the units. Either both should be in meter or both in centimeter. See, volume will be in cubic units. That cannot be brought to meter. Volume will be in cubic units. So it should be meter cubed and meter. It's like if volume is in meter cubed, then the radius should be in meter. Or if volume is in centimeter cubed, the radius should be in centimeter. So like that. Meter cubed and meter, or centimeter cubed and centimeter. So what we do here is 70 centimeters. To convert centimeter to meter, 70 by 100. To convert centimeter to meter, 70 by 100. So 1 0 and 1 0 cancel. So 7 by 10 meters. So now volume of the cylinder is 1.54 meter cubed. Pi r square h is. Now here, what is this 154 by 100? This is not converting meter cube to centimeter cube or something. No. I'm just shifting the decimal point. See, like if you have 0.7, we can write it as 7 by 10. 0.7 is nothing but 7 by 10. So like that, we're just moving the decimal point. 154 by 100. So here, it's not converting meter cube to some other unit. No, we're just shifting the decimal point. This is meter cube only. We're just shifting the decimal point. So it'll be 154 by 100. So 22 by 7 into R is 7 by 10 meters. So 7 by 10 into h is equal to 154 by 100. Work this and find the value of h, 1 meter. In the second solution, radius is in centimeter, 70 centimeter, because diameter is 140. So radius is 70 centimeters. Volume is in meter cube. So we are taking radius in centimeters. So we have to convert meter cube to centimeter cube. So meter to centimeter is into 100. So meter cube to centimeter, meter cube to centimeter cube will be into 100 3 times. So 1, 2. So 2 zeros and shifting the decimal point, they get cancelled. So we need to add 4 zeros, 2 zeros and 2 zeros, 4 zeros. When you find this product, 1.54 into 100 will become 154. And 154 into 100 into 100. So into 100 into 100. So that's what you see here. So now we have converted volume, this volume to centimeter cube. So we'll continue to have the radius in centimeter, 70 centimeter. So work that you get 100, h is equal to 100 centimeter, because you have the values in centimeter cubed and centimeter. So the answer which you get will be in centimeter, 100 centimeter, which is nothing but 1 meter. 100 centimeter, which is nothing but 1 meter. In the last one also, it is, I'm having both in meters, like radius in meter and volume in meter cubed. But here I've written the radius as 0.7 meters. 0.7 meters. Because this gets cancelled, 7 by 10 is nothing but 0.7. So pi r square h is equal to 1.54, 22 by 7 into 0.7 into 0.7 into h is equal to 1.54. This 1.54 is meter cube. This one is meter. So h is equal to, all these will come as reciprocals to the other side. So this is 0.7 by 1, 0.7 by 1. So it becomes 1 by 0.7 on the other side. H is equal to 1.54 into 22 by 7 will become 7 by 22. 0.7 by 1 will become 1 by 0.7. Now, 2 decimals shifted in the denominator. So 2 decimals will get shifted in the numerator also. The denominator, 1, 2. We are shifting 2 decimal places. So do the same thing in the numerator. Shift 2 decimal places. 1, 2. So in the next step, we are shifting 2 decimal places both in the numerator and in the denominator. In the numerator, 1.54 becomes 154. In the denominator also, 0.7 becomes, when the decimal point is shifted here, it becomes 7. This one, when the decimal point is shifted here, it becomes 7. Yeah, then when you simplify, 7 and 7 gets cancelled. 22 ones are, 22 sevens are, 7 ones are, 7 ones are. So h is equal to 1 meter. Meter because this is in meter cubed and we have this one in meters. So height is 1 meter. Yeah, you can ask me any questions, children. This conversion is very important. It's very simple also. Whatever you do to convert one unit to another unit, do that same thing 2 times or 3 times. If you have to convert a square unit to square unit, cubic unit to cubic unit. Same thing, if you're multiplying once, multiply 2 times for square units, 3 times for cubic units. If you're dividing, so divide by that number once when you're converting one unit to another unit. 2 times when you're converting square units to square units. 3 times for cubic units to cubic units. That's all. A milk tank is in the form of a cylinder whose radius is 1.5 meters and length is 7 meters. Find the quantity of milk in liters that can be stored in the tank. So here we just have to find the volume. Volume is pi r square h. Volume of the tank is pi r square h. So values are given to you, substitute and you'll get the volume in meter cube. The volume will be in meter cube. But you have to find the quantity of milk in liters. They've specified the unit here. See, find the quantity of milk in liters that can be stored in the tank. So when you find pi r square h, that will be the volume of the milk or the quantity of milk that can be stored in the tank, pi r square h, because cylindrical tank, no? So when you find pi r square h, you will get the capacity or the quantity of milk that can be stored in the tank. But this answer which you find will be in meter cube. You will find pi r square h, volume of the tank. But that answer will be in meter cube. Why? Because the radius is in meter and the height is also in meter. See, they're saying length of the cylinder because it's horizontal. Yeah, they're saying length of the cylinder because it's horizontal. Like this it is. So length of the cylinder. So don't get confused. If it's vertical, we say height. If the cylinder is vertical like this, then we'll not say, we'll not say what length. We'll say height. We'll say height of the cylinder. When it is horizontal, when the cylinder is horizontal like this, when the cylinder is horizontal like this, we call it length. When the cylinder is vertical, like you see in the figure here, then we call it height. So when you find the volume will be in meter cube because the radius is in meter, the height or the length is in meter. So meter cube. You need to convert that to liters. I'm going to write two formulae. Memorize this one. I'll just come back, children. Please memorize this. I'll just come back. Yeah, thank you, children. So now let's understand this relationship. What is this 1 meter cubed is equal to 1000 liters? We'll understand that first. Now let's imagine a cubical container of edge 1 meters. A cubical container. Okay, a container in the shape of a cube of edge 1 meters. So I'm not drawing it cubical. Okay, so the edge is 1 meter. Sorry, children, I don't know why I'm coughing. But 1 minute. Yeah. So a cubical vessel of edge 1 meter. So the volume of this cubical vessel, volume of a cubical vessel is equal to A cubed or edge cubed. Whatever is the edge cubed, A cubed is the volume. So 1 cube, which is 1. And because the edge is 1 meter, its volume will be 1 meter cubed. Because 1 cubed is 1 into 1 into 1, which is 1. If it was 2, then 2 into 2 into 2 is going to be 8. So this is 1. The edge of the cubical vessel is 1 meter. So its volume is 1 into 1 into 1, 1 meter cube. So now the capacity of this vessel, whose volume is 1 meter cube, is 1000 liters, is the meaning. That is, this cubical vessel can hold 1000 liters of liquid. A cubical vessel of edge 1 meter has a volume of 1 meter cubed. This cubical vessel of volume 1 meter cubed can hold 1000 liters of liquid, is what is meant by this relation. 1 meter cubed is equal to 1000 liters. It need not be a cubical vessel. It can be any vessel, any container whose volume is 1 meter cubed. I used a cubical vessel so that it's easy for me to take the edges 1 and find its volume as 1 cubed. For that sake, for the sake of convenience and explaining, I considered a cubical vessel. It can be any vessel, any shape. If the volume of that vessel is 1 meter cubed, then that vessel can hold 1000 liters of liquid, is what is meant by this relation. 1 meter cubed is equal to 1000 liters. Now the second one is 1000 centimeter cubed is 1 liter. What is this? 1000 centimeter cubed is 1 liter. So that means imagine a cubical vessel again of edge 10 centimeters. A cubical vessel of edge 10 centimeters, and 10 centimeters you can imagine with your scale, no? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 centimeters. So length of the cube 10 centimeters, breadth of the cube 10 centimeters, height of the cube 10 centimeters. So a cubical vessel of edge 10 centimeters. So the volume of this cubical vessel will be 10 into 10 into 10, 1000 centimeter cubed, because the edge is 10 centimeter. Okay, the edge of the cube is, the edge of the cubical vessel is 10 centimeter. So the volume of this cubical vessel will be 10 into 10 into 10, 1000 centimeter cube. Now this vessel whose volume is 1000 centimeter cube can hold 1 liter of liquid. 1 liter, because it's just 10 centimeters. You can imagine your scale, 10 centimeters. How much 10 centimeters is? Not very sure. Okay, something like this. So length 10 centimeters, breadth 10 centimeters, and height 10 centimeters. So that vessel can hold 1 liter of liquid. So a container whose volume, a container, any shape, it can be a conical container, cylindrical container, a cuboidal, cubical, whatever container. Any container whose volume is 1 meter cube can hold 1,000 liters of liquid. And a container whose volume is 1,000 centimeter cubed can hold 1 liter of liquid. If the volume of the container is 1 meter cubed, it can hold 1,000 liters of liquid. If the volume of the container is 1,000 centimeter cubed, it can hold 1 liter of liquid. Okay, so here we have to find the volume of the tank. Okay, that we'll get in meter cubed. Why? Because the radius is in meters and the height of the tank is also in meters. So the volume will be in meter cube. Now we have to convert this volume, which is in meter cube, to liters. That's all. Find the quantity of milk in liters. Nothing. We'll find the volume in meter cube, and using this conversion, you know what we just saw, we'll convert the volume in meter cubed to liter. That's all. So you can see here, capacity of the tank is pi r square h, pi r square 1.5 into 1.5 into h 7. So that works to 49.5 meter cube. Finished. Actually, we found the answer. That's all. The capacity of the tank is 49.5 meter cube. Done. But they don't want the capacity in meter cube. They want you to find the capacity in liters. So that means you should convert this meter cube to liters. So sometimes, you know, we are caught up with should I multiply or divide. So you can use this proportion. You can use this proportion method. You don't even have to write this actually. You can write this straight away. But I'll tell you what I've written. Okay, I'll just tell you what it is. So this is the general rule. What you see here is a general rule. 1 meter cube is 1,000 liters. Then 49.5 meter cube is how many liters? So how do we read this? It's a proportion. 1 meter cubed is to 1,000 liters is as to, this is to, this is as to. Okay, see, you might have seen all this in grammar, no? In English, if it's given like okay. Say like okay. A dog is to a puppy is as to a cat is to a what? A dog is to a puppy is as to a cat is to a, when it's dog, it's puppy. Then for a cat, it should be a
Kitten.
kitten. Cat is to a kitten. A dog is to a puppy is as to a cat is to a kitten. That's how we read this also. That's how we read this. 1 meter cubed is to 1 meter cubed is to 1,000 liters is as to 49.5 meter cubed is to X liters. We don't know. So we are calling it X. This is the general rule. This is what we are trying to find. If you write meter cube first and then liters, here also you should maintain the same order. Meter cubed and then liters. Meter cubed, liters. Here also meter cubed, liters. That order is important. So now this is 2. Now in mathematics, when we write 5:3, it's nothing but 5 by 3. Is 2 is nothing but division in maths. When we say A is to B, it means A by B. So now this S2 means 1 meter cubed divided by 1000 liters. And this is as 2 is nothing but equal to. Is as 2 is nothing but equal to. So 1 meter cubed divided by, because S2 is divided by 1000 liters. This one is equal to this one divided by X liters. Divided by X liters. Now cross multiply. Cross multiply. You can just write the numbers also. You don't have to mention the units. You can even write only the numbers. Cross multiply. So you have X liters into 1 meter cube is equal to this into this. The next step I've written them without the units. I've not written the liters and meter cube, this liters and meter cube. Without the units I've written in the next step. X into 1 is equal to 1000 into 49.5. So X is equal to 1000 into 49.5 by 1. X is equal to 49,500 liters. See, you can do it very quickly. Now, just for, for the sake of clarity, I've given so many steps. You don't have to write like so much in detail. See, we can do it quickly like this. 49.5 meter cubed it is, right? So 1 meter cubed, first you write this, 1 meter cubed by 1000 liters is equal to 49.5 meter cubed divided by X liters. Now next step, cross multiply. So it'll be X into 1. You can write X straight away. See, X into 1 is X. You don't have to write X into an X is equal to 49.5 into 1000 into 1000. So X is equal to 49512 liters. Finished. First you write the general rule, 1 meter cubed by 1000 liters is equal to, here we have 49.5 meter cubed. So this one will be how many liters? X liters. Now we have to cross multiply. Don't write this meter cubed and liters. X into 1 is X is equal to 49.5 into 1000, which is 495 followed by 2 zeros. Finished, we got it. So it need not be so much in detail. You don't have to give so many steps. All right. Okay. So here, since the volume is in meter cubed, we have to use that relation. 1 meter cubed is 1000 liters. Supposing the volume was in centimeter cubed. Supposing the volume here was in centimeter cubed, then you have to use the other relation. 1000 centimeter cubed is 1 liter. That relation you'll have to use. To convert meter cube to liters, what we just used. If you want to convert centimeter cube to liter, then you should use a relation 1000 centimeter cubed is equal to 1 liter. So supposing the answer was, supposing the volume is say like some 50,000 centimeter cube, and we need to find this volume in liters. Supposing the volume is 50,000 centimeter cube, then you should write 1000 centimeter cubed means 1 liter. 50,000 centimeter cube is how many liters? This is the general formula. This is the situation now. We have to convert. If 1000 centimeter cubed is 1 liter, then 50,000 centimeter cubed is how many liters? X liters or Y liters. Cross multiply. X into 1000. When you cross multiply X into 1000, see, you should have centimeter cubed in the numerator and liter in the denominator, or have liter in the numerator and centimeter cubed in the denominator. Numerators must be 1 unit. The denominators must be again the same unit like. So in the numerator here I have centimeter cubed on both the sides. Denominator I have liter on both the sides. That is very important. So on cross multiplying, x into 1000 is equal to 50,000 into 1, which is 50,000. So x is equal to 50,000 divided by 1000. 50,000 divided by 1000. 3 zeros gets cancelled. 50 liters. So 50,000 centimeter cube means 50 liters. So here, if each edge of a cube is doubled, how many times will its surface area increase? How many times will its volume increase? Okay. All right. So the edge is doubled. So A becomes 2A. A becomes 2A. Original edge A. New edge 2A. Harsha is not there now. Lakshana and Ariston, are you there, both of you?
Yes, ma'am.
Okay. Ariston. Your mic is not working. Okay. All right. So surface. So we have to first find how many times will the surface area increase. So let's find the surface area of the original cube and the new cube. Only then you can compare. You must know the surface area of the original and the new. Only then you can compare. So the surface area of the original cube will be 6a square itself because the edge is A. The edge is A. So the surface area of the original cube will be 6a square itself. But the surface area of the new cube will be 6 into the edge is 2a. So 2a the whole square. The formula to find the surface area is 6 into edge square. Whatever is the edge squared. 6a square. So 6a square meaning 6 into edge square. So 6 into the edge is now 2a. So 2a the whole square. So the 6 into 4a square. Because 2a into 2a is 4a square. So 6 into 4a square, which is 24a square units. So what was the original surface area? 6a square. Now what is the surface area? 24a square. So 6a square into 4 is 24a square. So the new surface area is 4 times the original surface area. Original edge A, a new edge is doubled, so 2a. Original surface area is 6 into edge square. A square. This is the original surface area. The new surface area is 6 into, this is the edge, the new edge square. So 6 into 4a square, 24a square. So 6a square has become 24a square. 6a square into 4 is 24a square. So the new surface area is 4 times the original surface area. Next is volume. Original volume is a cubed. The new volume will be 2a, the whole cubed, because the new edge is 2a, not 2a cubed like this. The edge is 2a. That edge, entire thing should be cubed. If we write 2a cubed, it's wrong. Whatever is the edge, that should be cubed. So what is the edge? 2a. The whole thing has to be cubed. So 2a into 2a into 2a, 2a into 2a into 2a, 8a cubed, 8a cubed. So 2A the whole cube, which is the 8A cube cubic units. So what is the original volume? A cube. Now how much has it become? 8A cube. How? Into 8. A cubed into 8 is 8A cube. So the new volume is 8 times the original volume. Because A cubed, the original volume, has now become 8A cubed. A cubed into 8 is 8A cubed. So the new volume is 8 times the original volume. Any questions here? Lakshana and Ariston?
No, ma'am.
No, ma'am.
All right. Water is pouring into a cuboidal reservoir at the rate of 60 liters per minute. Water is pouring into, you can see the picture also. Water is pouring into a cuboidal reservoir. Reservoir is you're storing water for the future. You're storing water somewhere, reservoir. Water is pouring into a cuboidal reservoir at the rate of 60 liters per minute. In 1 minute, 60 liters of water is being filled into the reservoir. If the volume of the reservoir is 108 meter cubed, the volume of the reservoir, that is the capacity, the entire capacity of the reservoir is 108 meter cubed. Find the number of hours it will take to fill the reservoir. So see here. So the volume of the reservoir is in meter cube. If we convert that to liters, then we can understand better. So we'll convert it to liters and then we'll try to understand the question. We'll just try to come because the rate of filling per minute is given in liters, 60 liters per minute. But the capacity of the reservoir is in meter cube. So it's difficult to understand the situation. We understand the situation, but difficult to answer this. So what we'll do, since this is in liters, we'll convert this also to liters. So 1 meter cubed means 1000 liters. So 108 meter cube will be 108,123 liters. Because 1 meter cubed is 1000 liters, no? So 2 meter cubed will be 2000 liters. 3 meter cube, 3000 meters. 4 meter cube, 4000 liters. So 108 meter cube will be 108,000 liters. I hope we understand. 1 meter cube is 1000 liters. So 108 meter cube will be 108,000 liters. Now let's understand the question. The rate of filling is 60 liters per minute. The volume of the reservoir is this one. The question is find the number of hours it will take to fill the reservoir. So 60 liters is filled in 1 minute. 60 liters is filled in 1 minute. So 108,000 liters will be filled in how many minutes? That's all. In 1 minute, 60 liters is filled. In 2 minutes, 120 liters will be filled. In 3 minutes, 180 liters will be filled. In 4 minutes, 240 liters. 5 minutes, 300 liters. So in how many minutes will 108,000 liters be filled? In how many minutes will 108,000 liters be filled? So you'll have to divide 108,000 divided by 60. Divided by 60. So 0, 0, 6 ones are 6 ones are 6, 8s are 48, 0, 0. So many minutes? 1,800 minutes. And 1,800 minutes means how many hours? You'll have to divide by 60 to convert that to hours. To convert to hours, divide by 60. So 30 hours. It'll take 30 hours. It's a very simple question. Just that the rate of filling is given in liters per minute, but the volume is given in meter cube. So when they are in two different, when the capacity is in two different units, it may be difficult to understand the situation or answer the question. So have both in the same unit. Convert 108 meter cubed also to liters. Then it's easy to answer the question. So I told you also, I've worked in detail so that you understand. You can, once you understand, you can, reduce the number of steps shown here. So here we are converting volume of the reservoir is 108 meter cube. So 1 meter cube means 1000 liters. 108 meter cube means how many liters? I told you can even ignore this step. 1 meter cube is 1000 liters. 108 meter cube is how many liters? So cross multiply, x into 1 is x. X into 1 is x. And 1000 into 108 is 1,80,000 liters. So this is the volume of the reservoir. Now again, you can use this proportion. 60 liters is filled in 1 minute. Then 1,80,000 liters will be filled in how many minutes? Since I've used x here, I'm using y here, that's all. 60 liters is filled in 1 minute. Then 1,80,000 liters will be filled in how many minutes? Liter, minutes, liter, minutes. The same thing here. 60 liters is filled in 1 minute. Then 1,80,000 liters is filled in how many minutes? Y minutes. Cross multiply. 60 into y. 60 into y is equal to 1,80,000 into 1. So y is equal to 1,80,000 by 60. So many minutes. And to convert it to hours, you should divide by 60. And that gives you 30 hours. So the reservoir will be filled in 30 hours. Yes, Ariston and Lakshana. Any questions? You want me to repeat this answer or any part you have a doubt? Both of you?
No, ma'am.
All clear, ma'am.
Okay. All right, children. Just open some of the material, just a minute. Yeah. Yes, Ariston, what's the formula to find the area of a circle? Lakshana, formula to find the area of a circle?
Pi r square.
Pi r square. So what is given here? The area of two circles are in the ratio 49:64. That means pi r square by pi r square is equal to 49/64. This is what is given to us. The area of two circles are in the ratio 49:64. So 49:64 means 49 is a smaller circle, 64 is the bigger circle. From the ratio, you can make out that this one, the numerator represents the smaller circle, the denominator represents the larger circle. So I've used small r for the smaller circle and capital R for the larger circle. And area is given by the formula pi r square. So pi r square by pi r square is equal to 49 by 64. Pi gets cancelled. So we have r square by r square can be written as r by r the whole square. R by r the whole square. Okay, is equal to 49 by 64. So r by r is equal to the square root of 49 by 64. R by r is equal to 7 by 8. So if the ratio of the areas of the two circles is 49 by 64, the ratio of the radii will be 7:8. Now the question is to find the ratio of their circumferences. So required ratio is equal to 2 pi r by 2 pi r. We need to find the ratio of their circumferences. So the required ratio is 2 pi r by 2 pi r. 2 pi gets cancelled. So r by r is 7 by 8. So this is the required ratio. The ratio of their circumferences is 7 by 8. I'll send the picture in the group. You don't have to write now. Yeah. A bicycle wheel makes 500 revolutions in moving 1 kilometer. Find the diameter of the wheel. So this is the wheel of the bicycle. Now in one revolution, the distance covered is 2 pi r. When the wheel makes one complete revolution, the circumference of the circle goes over the ground. That means 2 pi r. The distance covered by the wheel in one revolution is equal to 2 pi r. Why 2 pi r? Because it's a circular wheel. Bicycle wheel, it's circular. So when it makes one complete revolution, the circumference would have gone over the ground once. And the length of the circumference is 2 pi r. So the distance covered in one revolution is equal to 2 pi r. So remember this formula. Distance covered in one revolution into number of revolutions is equal to the total distance covered. Total distance. So supposing the wheel of the bicycle, it is able to cover, say like 1 meter. That's too much. 1 meter is too much. I'm just using it to explain. So supposing the wheel, okay, say not of a bicycle, some wheel, it's able to cover 1 meter in one revolution. Some wheel in one revolution, it is able to cover 1 meter. So in 10 revolutions, it will cover 10 meters. So in 50 revolutions, it will cover 50 meters. So the distance covered in one revolution into the number of revolutions will be the total distance covered. It's a very simple equation. The distance covered in one revolution into the number of revolutions will be the total distance covered. So the distance covered in one revolution is nothing but 2 pi r. The distance covered in one revolution is nothing but 2 pi r into the number of revolutions. It's given there, 500, is equal to the total distance covered, 1000. Now, you can write 1 kilometer. You can also write 1000 meters. 1000 meters. 1 kilometer is 1000 meters. 1000 meters. Distance covered in one revolution into number of revolutions is equal to the total distance covered is the equation. The distance covered in one revolution is 2 pi r into the number of revolutions is 500 is equal to the total distance covered is 1 kilometer, which is 1000 meters. So 2 into 22 by 7 into r. We don't know. That's what we have to find. 2 into 22 by 7 into r. You can take that 500 to the other side for division is equal to 1000 by 500. So it will be 2. So r is equal to 2 into 2 will become 1 by 2 here. And 22 by 7 will become 7 by 22 here. 1000 by 500 is 2. Now this 2 and 22 by 7 has to be transposed. 2 comes as 1 by 2 and 22 by 7 comes as 7 by 22. So r is equal to 2 into 1 by 2 into 7 by 22 cancels. So radius is equal to 7 by 22 meters. You can see this is in meters. So meters, but we have to find the diameter. So the diameter will be equal to 2 into r, 2 into 7 by 22. So 2 ones are 2 11s are 7 by 11 meters. 7 by 11 meters. Tell me, I'm going to clear the screen and work this again. Yeah. So tell me the formula first.
Ma'am, I have a doubt.
Yeah.
Converting kilometers into meters.
Yeah. 1 kilometer is 1000 meters.
Yes, ma'am, but why can't we solve it keeping like 1 kilometer instead of converting it into 1000 meters?
Yeah, we can do that. We can do that also. Yes. We'll do that.
Yes, ma'am.
Yeah, that's fine. The thing is, okay, the value will not be understandable. For the value to be understandable, you'll have to have it in smaller units. That's all it is. We'll do it. We'll keep it as 1 kilometer and do it. Tell me the formula.
2 pi r.
No, the formula. Distance covered. Distance covered in one revolution. Distance covered in one revolution into number of revolutions is equal to total distance covered. Yeah. Now, what is the distance covered in one revolution? 2 pi r. And the number of revolutions? 500. And the total distance covered? You want to keep it as 1 kilometer. You should convert it to meters to understand the final answer better. But if you keep it in kilometer also, it's fine. It's not that you should not do it. Now, I'll tell you 1 minute. I'll tell you. Now, when you were in 6th or 7th standard, if you had to find 25% of, say, 1 day, 25% of 1 day, you would have done it, you would have worked it like this. 25% is 25 by 100. Off is into 1 day, you will take it as 24 hours. You will not write 1 here. You'll take 24 hours, and you'll simplify this and give the answer. So in the same way, find 25% of 1 kilometer. So you'll say 25% is 25 by 100. Half is into, you'll not take 1 here. You'll take 1000 meters. Because you can cancel the 2 zeros, and the answer you get is 250 meters, which is easy to understand. Okay, 250 meters. But if you take 1 kilometer, 25 by 100 into 1 kilometer, you will get 1 by 4, 1/4 of a kilometer, like this. So we prefer this answer, 250 kilometers over 1/4 of a kilometer. This answer is preferred because it's easier to understand. Supposing it was 1/11 of a kilometer. It's not so easy to imagine how much that is. But when you have the answer like this, it's easy to understand. That's all it is. But the answer is the same. 1/4 of a kilometer is the same as 250 meters. Just the 250 meters is easy to understand. It's just for that reason. So you can take this one here. Next, 2 into 22 by 7 into R is equal to, you can take the 500 to the other side. You'll have to transpose. To find the value of R, you have to take all the numbers to the other side. In order to find the value of R, you have to take all the numbers to the other side. So it will be is equal to 1 divided by 500. Then R is equal to 1 by 500 into 2 by 1 will become 1 by 2. 22 by 7 will become 7 by 22. So R is equal to, you can see what you're getting here. 7 by 44 into 500. 44 into 500. So you get 7 by kilometers. This answer will be in kilometers. It's right. And now we'll have to find the diameter. So diameter will be equal to 2 into 7 by twice radius. So 2 into this one. So diameter will be equal to 2 ones are 2, 11 followed by 3 zeros. So 7 by kilometers. Is also fine. Supposing it's a multiple choice question and the diameter is in kilometer, you can work it like this. All right.
Yes, ma'am.
Yeah, but so again, so like if you have to find 20% of 1 year, you will write 20% is 20 by 100 into 1 year is maybe you'll take 365 days or you'll take 12 months. You'll not take the number 1. So that's what it is. Okay. So if your question is now in the exam, should we go ahead with kilometer or meter? Both is fine. If nothing is specified, if the question is find the diameter of the wheel in meters, then of course you have to change. You can even change the final answer to meters. Because 7 by 11,000 kilometers will be 7 by 11,000 into 1,000. To convert kilometers to meters, we'll have to just multiply by 1,000. So you can convert it in the final step also. You can take 1 kilometer here. The final answer you get will be in kilometer. You can change this to meter. So you can change 7 by so many kilometers to meter. 7 by into 1,000 meters. So 3 zeros and 3 zeros cancels. So 7 by 11 meters. Is that fine?
Yes, ma'am.
Okay. I'll work this in both the ways and I'll share it on WhatsApp later. That is by taking 1,000 meters in the first place, and also by taking 1 kilometers and then converting it to meters. Maybe I'll do it like that itself, because like you asked, most of us will have that question. Why? How do we know that we have to convert 1 kilometer to meters straight away? So let me do it like this itself. All right. Any more questions, Lakshana and Ariston?
No, ma'am.
Okay. All right, Ariston and Lakshana. That's it for today's session. So with this, we have finished mensuration from NCERT. Our next class, I'll be sharing the recording with the children. So I hope they watch the recording completely by the time they come to the next class. So we'll take up a revision session on mensuration in the next class. So please come prepared with the formulae, not for the entire class, not for the entire class, but I'll just select a few questions, and maybe for about 45 minutes to 1 hour, we'll just check how much we have understood of this chapter. All right, so please come prepared with the formulae. All right, children, that's it for today's session. Thank you so much. Good night. You may leave the call.
Thank you, ma'am.
Thank you. Yeah, thank you, Ariston. I saw your message. Thank you.